Well, I did contact somebody about the projector yesterday, so hopefully that'll get fixed here one of these days. So in the meantime, I think what I'll probably do is just project it over on the wall like I was doing before here. So let me just go ahead and log in here. So just a couple things here to mention to everybody is I did manage to post the first couple of classes online, or at least since I started taking earlier this week. So if you want to look at those or anything, and I'm not sure how long they will remain up there, depending on the space limitations. I may have to remove some of the older ones as I post the newer ones, but I think I did get the first couple of lectures up there. I don't have the one from yesterday up there, which you guys might be interested in seeing, I guess. But I'll let you know if and when I can get that up there. I'm trying to convert it right now. It takes about an hour for me to convert the video to a format that's easy to post. And keep in mind, depending on the speed of your computer, it may take a while for the videos to download. I think it's only been taking me about 5 minutes or so, maybe a little bit less to download them on my computer. So, but just be patient. And if you can't view them or anything, let me know. I'm not sure. I guess that most of them are in MP4 format, so I don't know if that'll be the most useful format for you guys or not. But if there are other formats that you would find useful, please let me know, and I can maybe convert them into that as well. Okay, so I guess I should tell you guys too what section I'm gonna collect, and I think what I'll probably collect today is section 1.2. So now remember, it's not due till the end of class. So if you have a few questions, I'll take questions as usual. Let me take questions on that first. I know a lot of you might have questions on the other sections, but let me take questions on that first, and then we'll move on to the next section. Okay, so did anybody have any questions then, just from 1-2? No questions from just 1-2? Anybody have questions about other sections? Okay. Well, if nobody else had questions, then I guess we'll move on to the next section. Oh, yeah. I'm sorry. Let's see. Yeah.
For 97 and 1-5.
Okay.
I was wondering which number first in the subtraction.
Oh, so this is.
Do a number line.
Okay, so this is where you got 12 less than the difference between 8 and -5. Is that the one you're talking about?
Yeah.
So this is 1.5 number 97. Right? So let me just read this one here in case anybody doesn't have their book. But it says it says above 83 to read the directions there. It says write a numerical expression for each phrase and simplify. And then it says see examples 7 and 8 if you need some examples. So number 97 says that you've got 12 less than the difference between 8 and -5. Okay, so now, like I said, when you're subtracting, the order makes a difference here, so you need to be a little bit careful. So let's think about it this way. So you're taking 12 less than something, right? So that means you're taking something and subtracting 12 from it, right? Because you want it to be 12 less than something. So it's 12 less than what? Well, it's 12 less than the difference between 8 and -5. So when they say the difference between 8 and negative 5, how would you write that? Yeah, so the difference means to subtract. So, and again, like I said, when they use the word difference, just write things down in the order that they occur. So it says the difference between 8 and negative 5, that would mean that you're taking 8 and you're subtracting negative 5, and then that's what you're subtracting the negative 12 from. Does that make sense? So like I said, just be careful with these problems. If you just write things down in the order they appear, it says 12 less than the difference between 8 and negative 5, you might be tempted to write that as 12 minus, 8 minus a negative 5. So just be careful. So keeping that in mind here, now you have to follow the order of operations. Now that we've got the expression, because it does say to simplify. So now we need to simplify that. So now keep your order of operations in mind, right? Do what's inside the innermost set of parentheses first, which I guess would be this one. But there's really not a whole lot to do there, right? I mean, I guess you could maybe, there's really nothing you could do inside there. But what you could do is you could say, okay, well, I've got a negative of a negative, so that would make that a positive. So that would actually be 8 plus 5. Okay, and then again, within this set of parentheses, you want to do exponents first, but there aren't any. Do any multiplication and division in here, but there isn't any. And then lastly, do addition and subtraction from left to right. So the only thing in there is addition and subtraction, right? Take 8 plus 5, that'll give you 13. Again, once you've simplified everything inside the parentheses, you can get rid of the parentheses there. So you can remove the parentheses around the 13. And then again, just go back to the beginning, right? No parentheses in here, no exponents, no multiplication and division. So lastly, do addition and subtraction. And 13 minus 12, that should give you a 1. Does that make sense for that? Just double check and see if that's. So again, like I said, especially be careful when you're dealing with subtraction because the order will make a difference. Okay, so any one of those days again. So okay, so any questions about anything else from the first couple sections, especially 1, 2? Remember that's due today, so if you have a couple questions you couldn't get on there, you can still ask. So, any other questions about this one or anything else? Okay. Okay, well, look over your stuff here, and I just wanted to show you where the videos are located, and I don't know. Like I said, I'm not sure how many I'll be able to put up there at a time. I'm surprised I haven't crashed Blackboard yet. So, I may have to, depending on how much space I've allocated here, I may I may have to remove some of the videos after a while, so if I can find another storage option, I guess I could always try to email them to you or something if it would be possible to email such a large file. But so if you just go to your class, which is this one, just go under, so all the stuff is just posted in the course documents, like the notes and stuff. So, try opening this. So I don't know how long this will take to open. I guess you get an idea of how long it will open. Like I said, I don't have the one from yesterday, which you might find kind of entertaining to watch again. But I'm transferring it right now, so it should be up shortly after class, hopefully. So anyway, let me leave that run for a little while so you can see how long it'll take to load there. Keep in mind the network here on campus is fairly fast, so if you're doing this on your home computer at home, it could take considerably longer to download. Now let me open up the notes and stuff while that's loading. It didn't take too long on my computer, but it's an hour video footage, so it's kind of a big file. It's about 500,000 kilobytes or something like that. Okay, so I guess it might take me a while to open my notes here too. So any questions then about anything else before we move on to the next section? So any other questions about 1 and 5 or 1 and 4? Okay. Well, if everybody's okay, let's go ahead and move on to the next section here then. So we talked about adding and subtracting positive and negative numbers, and so the next sort of logical thing would be to talk about multiplying and dividing, which is what the next section is about. And we've only got a couple sections left again, just to give everybody an idea of when the exam might be. If we get through this section today, and it's kind of a lengthy one, so it might take us a couple days. If we get through this one today, I think we've got 2 more sections. So 8-7 we'd probably do on Monday, 8-8 we do on Tuesday. Maybe a review on Wednesday, and then take the exam probably either Thursday or Friday of next week, I think. So just keep that in mind. And I'll be posting a sample exam sometime toward the middle of next week, and we can go over that on the review day if you want. Let me just see how this is doing here. Okay, well this will probably come on in the middle of my lecture or something, so I hope it's not too noisy. But maybe I should just shut it off. You can see it does take a while to load, right? It hasn't loaded yet, but I think in most cases it should open in like QuickTime or something like that. Okay, so again, the ideas in this case, we're looking at multiplying and dividing positive and negative numbers. I don't know about you guys, but I always thought multiplying and dividing positive and negative numbers was easier than adding and subtracting, right? I mean, when you're adding or subtracting, sometimes you get a positive answer, sometimes you get a negative answer, depending on what you have more of, right? Whether you have more negatives or more positives. Now, when you're talking about multiplying or dividing, you always get the same answer. If you remember, basically the idea is if the signs are the same, the answer is positive, and if the signs are different, the answer is negative. And it's the same thing for both multiplying and dividing. Then we'll get into some sort of word problems and stuff at the end of this section. So one thing just to remind everybody about, first of all, is that if you multiply anything by 0, that gives you 0, right? Even if x is 0, right, 0 times 0 would still be 0. So just one thing to kind of remind everybody about here before we sort of jump into the multiplying by positive and negatives, right? Because I guess 0 isn't a positive or negative. Oh, here we go. So you can see how long it took to download there. I'm not a cinematographer, so I apologize if the video quality is kind of bad. But I may have somebody come in and try and tape the class for me at some point. But so I don't know how long it'll take to open here. We'll just let it open here in just a second. So the thing to remember is when you're multiplying numbers with different signs, if one's positive and one's negative, remember the result is negative. So basically the idea is if you take a positive times a negative, you get a negative. Okay. So just to give you some examples here, right? If you take 2 times negative 3, right, that gives you negative 6. Negative 5 times 7, right, that'll give you negative 35. What would negative 3 times a positive 8 be? That'd be negative 24, right? So the important thing is to remember that if you take a negative times a positive, you get a negative. Now if you multiply 2 negatives together, or anything, 2 things with the same sign, so this also applies to positive numbers. I mean, if you take a positive times a positive, you get a positive. Like a positive 3 times a positive 2, you get a positive 6. If you're multiplying negative numbers, the result is a positive. So for example, if you take negative 2 times negative 3, that gives you a 6, positive 6. Right? Negative 5 times negative 7 would give you a positive 35. What would negative 3 times negative 15 be? It would be a positive 45. Right? So just remember that if the signs are different, the answer is negative. If the signs are the same, the answer is positive. Okay, so just to sort of summarize what I just said here. So that's basically all you have to remember for this section, right? Is that if you have two numbers that have the same sign, right? If you're taking negative times a negative or positive times a positive, the answer is positive. If you're multiplying a negative times a positive, you get a negative. Now, one thing that may be mentioned here is there's kind of a shortcut you can use for this if you're multiplying a bunch of positive and negative things together. Like, so for example, if you take, say, like negative 1 times 2 times negative 1 times 1 times 3, the idea is if you're multiplying a bunch of numbers together like that, you can determine whether the answer is going to be positive or negative based on the number of negatives you have. So the idea is if the number of negatives is even, if the negative numbers are even, then the answer is positive. So, I mean, you can think about it this way, right? I mean, the idea is if you take a negative 1 times a negative 1, right, that will give you a positive 1, and then everything else is positive, so you'll get a positive, right? So, and if you have, and if the number of negative numbers is odd, the answer will be a negative. So, for example, if I was to take like negative 1 times 2 times negative 2 times negative 1 times 3. Like the answer for this one would be 6, I guess, right? Because you're just really taking 2 times 3 and then everything else is a 1. Same thing here, right? I mean, so you get 2 times 2, which is 4, times a 3, which would be 12. And then the answer should be negative because you've got 1, 2, 3, you've got an odd number of negatives. So the answer there would be negative 12. Okay, so for example, if I was to take like negative 1 times negative 1 times negative 2 times 1 times negative 1 times 3 times negative 1 times a negative 2, would that result be positive or negative? So don't worry about what the actual number would be. Would that answer be a positive or negative answer? Yeah, so count the number of negatives you have. You have 1, 2, 3, 4, 5, 6. Since you have an even number of positives, the answer should be, or the even number of negatives, I'm sorry, the answer should be positive, right? So that would be a positive, and then just take 2 times 3, which is 6, times another 2 would give you 12, and the answer for that would be plus 12. So you can kind of generalize this if you're multiplying more than 2 things together. So just remember, if you're multiplying anyway, and the expression contains an even number of negatives, the result will be positive. If it contains an odd number of negatives, then the result will be negative. Okay, so now one thing I want to talk about then is reciprocals, and the idea in this case is that, you might remember that when you're dividing numbers, a lot of times, especially when you're dealing with fractions, you have to find the reciprocal of a number. So that's mainly the main thing, just to remind everybody about, is what the reciprocal means, right? If you have 3/4, the reciprocal is 4/3. If you have 2, you can really think of 2 as being 2/1, its reciprocal is 1/2. So again, when you're dividing sign numbers, remember the idea in this case is that it's similar to multiplication. The idea is if the 2 things you're dividing have the same sign, the answer is positive, and if the 2 things have different signs, the answer is negative. Okay, so, and so just kind of making a connection here between multiplication and division. And the idea is if you have something divided by something else, you can really think of that as multiplication. You can really think of that as x times 1 over y. Right? So you basically multiply by the sort of the reciprocal of y. So the idea basically is you can think of multiplication as really, or the division as really multiplication. If you want. So if you have, if you have 2 divided by 3, you can really think of that as 2 times 1/3. So just to give you some examples here, right? So if you've got, again, if the two numbers have the same sign, the answer is positive. So for the first one, you get a positive 5. For 9 over 3, you get a positive 3. For negative 6 over 2, since the top's negative and the bottom's positive, you'll get a negative 3. Right? For 8 divided by negative 2, you'll get a negative 4. So just like multiplication, right? If the two things have the same sign, the answer is positive. If they have different signs, then the answer is negative. Just to give you a couple of other examples here, if you look at, say, for example, 6 divided by 3, right, and you don't necessarily have to think of it this way, but you can think of that as 6 times 1/3, which would just be 2. Or if you have negative 18 divided by 6, you can think of that as negative 18 times 1/6, right, which would be negative 3. Okay, now the only other thing that you really have to worry about then is when you're dividing is, what happens if the number you're dividing by isn't positive or negative? What if it's 0? So you might remember that division by 0 is undefined. You can't really divide by 0. Remember, and be careful, don't get this messed up, but right, if you divide by 0, that's undefined. But if you divide 0 by something, that is 0. Right? I mean, if you ask yourself, how many times does 7 go into 0? Right? It goes in there 0 times. Right? So if the top is a 0, the answer is 0. If the bottom is 0, it's undefined. And we won't worry about 0 divided by 0. That's another case that can happen. We won't worry about that. Okay, so now just to sort of clarify some of the other properties here of division. The idea basically is you can kind of move the negative sign around to wherever you want. So if you have, if you have negative x divided by a positive y, you can really write that as an x or as x divided by negative y. You can think of that as negative x over y. So for example, just to give you some examples here with numbers like I have over there on the slide. If you have negative 2 divided by 3, I mean, if you think about what the answer for that is, right, you're dividing a negative by a positive, so the answer will just be a negative, right? Now 3 doesn't go in there evenly, but you can say that, the result will just be negative 2/3, or, you could write it as a decimal or something if you want. But you can also put that negative on the bottom because, the idea is if you took a positive 2 divided by negative 3, that would also give you negative 2/3. So the idea is if you have a fraction like this, where you've got a negative, you can kind of move that negative around wherever you want. You can leave it up in the top, you can put it in front of the fraction, you can put it on the bottom of the fraction, whatever you want to do. And likewise, if you have a, if you have a negative divided by a negative, right, the answer to that should be positive. So if both the top and the bottom are negative, you can kind of write it without the minus signs there. Okay, so any questions about any of that stuff so far? I mean, I know I've been going through that kind of quickly, but I'm sure you guys probably remember a lot of this stuff anyway. So, but any questions about that at all so far? Okay. So let's take a look at the next thing then, which basically is kind of, we're going to sort of do what we did with in the last section where we talked about word problems involving addition and subtraction. Now we're going to talk about word problems involving multiplication and division. But before we do that though, just to reiterate things, right? Again, the idea basically is sort of talking about the last two sections, right? Remember when you're adding, the answer basically depends on what you have more of, right? If the two answers have the same sign, then the answer will be negative or positive depending on the sign of the numbers. If they have different signs, then again the idea is the one that you have more of, that will be the answer. If you have more negatives, the answer will be negative. If you have more positives, the answer will be positive. And then subtraction, again, that's basically the same thing as addition, right? You're just adding a negative. And then again, for multiplication division, it's a lot easier, right? If they have the same sign, then the answer is positive. If they have different signs, the answer is negative. And that's also true, again, even if you're multiplying or dividing a bunch of things. Again, you can just basically count the number of signs, just like we did for multiplication. So the idea is, let's say you've got a -1 times a -2 times a 3 all divided by like a -2. Right? Just count the number of negatives you have, and if the number of negatives is odd, the answer will be negative, just like multiplication. So the idea here is I've got 1, 2, 3. That's an odd number, so that means the answer to this will be negative. In fact, it will be a negative, right? Because 2 will divide into 2 there, right? And then -3 there. Or if you have something where you've got -1 times 1 times 3 times -2 divided by -1 times -5 or something like that, right? What is the answer to that? Going to be positive or negative? Yeah, just count the number of negatives. You have 1, 2, 3, 4 negatives. If you have an even number of negatives, the answer will always be positive. And when you're multiplying and dividing, or in this case, I guess it'll be what, 6 fifths. Okay, so any questions about those before we look at word problems? Okay, so let's go ahead and talk about word problems involving multiplication. So now, just like addition and subtraction, there are key words that you want to use, or that you need to know a lot of times when you're dealing with multiplication. And so, words that mean the same thing as multiplication is the word product. Product means to multiply. Times, twice. Of, especially when you're using with fractions or you're talking about percentages, as much as things like that usually indicate multiplication. And there are other ones too. I don't remember if they state these in your book off the top of my head or not. Yeah, most of these are listed on that gray table sort of in the middle of page 60 there if you want to look that up. And again, it's, even if you know the key words, it's still, hard to sometimes translate the expressions, but at least, know some of the key words, especially the word product. And then there are certain key words for division also. There's quotient, divided by, ratio of, right? All of those things mean division, and those are listed, basically all those are listed on a box on the top of page 61. So anybody need those two slides? Okay, so the idea basically is, again, you can translate expressions into equations just like you did for addition and subtraction. So just to give you some examples here, let's say that you have the product of 5 and -6 is subtracted from 13. So product just means to multiply. So again, I'll have 13 minus 5 times -6, and I guess I didn't really need the parentheses around the 5 and the 6 there. And then once you've done that, again, just follow the order of operations, right? Multiply first, you'll get 13 plus 30, and then lastly add and subtract, right? 13 plus 30 gives you 43. Or you could have something where you've got the quotient of a number in -5 is 2, and in this case, you can't put a number, a number in for the word number. You have to use some sort of symbol. I guess I used a question mark over there. But you could do something like, you've got some number divided by -5 equals 2. In some cases, they might ask you to solve an equation like that for x. And I know we haven't really gotten to this yet exactly, but anybody have any idea how you could solve that for x if you wanted to? I mean, what would x have to be so that when you divided it by -5, you'd get 2? Yeah, it would have to be a -10. So remember, if you take a negative divided by negative, that should give you a positive. And you can just think of it as multiplying both sides by -5 too. The answer. Okay. So those are some examples. Let's just do a couple more for practice, and then I think that'll basically wrap up this section. Maybe I'll do a couple more examples from the book. Time. But, so in this case, you've got twice the product of -5 and 2 subtracted from 10. Okay, so why don't I have you guys help me with this one? How would I want to write that as a, as an expression up here that I can simplify?
2 times -5 plus 2.
Okay, so yeah, okay, so now what does the word product mean? That means to multiply, right? So you want to take -5 times 2, and it's good that you multiply by 2, so if you say, twice, a lot of times when people see that, they might think that you're squaring or something like that, but you're not taking it times itself twice, you're just multiplying it by 2, right? Just like if you have the number 10, twice 10 is 20, now 10 squared or 100. Okay, so you get that, and then what would you have to do? Yeah, and then so do I write it like this? Yeah, no, so again, be careful of the order, right? So remember, this thing here is being subtracted from 10, right? 10 is not being subtracted from that. So again, like I said, when you're doing subtraction, watch out for the order, right? It should actually be 10 minus whatever that is, right? So you're taking twice the product of -5 and 2. That thing is subtracted from 10. Okay, so is everybody okay with that? And so most of these are pretty easy, but some of them can be kind of tricky like this, so just be careful. And if you have questions, make sure you ask. So is everybody okay with that? Does that make sense to everybody before we simplify that? Okay, so if everybody's okay, let's go ahead and simplify that. So again, remember, we want to do the order of operations once we've got that up there. So what would I want to do first? Yeah, so simplify what's inside the parentheses. What would I want to do inside there? Yeah, so that would just give you -10, right? There's no exponents, no addition or subtraction or anything. So the only thing to do in there is multiply. And then what would I want to do?
Maybe 2 times 2.
Yeah, no, okay, now be careful depending on how you think of this, right? You might think that you're multiplying here, right? But if I meant to multiply those together, I'd put that around there. So be careful, right? If you have 10 minus 2, right? Remember that you want to do addition and subtraction last. And I am subtracting there, I'm not multiplying the 2 times the -10. So be careful, right? Remember there's implied multiplication here. So what would I want to do first? Take the 10 minus the 2 or the 2 times the -2? Yeah, so take that times that, so I'll get 10 plus 20. Right, because -2 times a -10 will give you a +20. And then last thing to do is just add them together, right? So that should be 30. Okay, so is everybody okay with that? And it is kind of hard to tell, like when are you multiplying and when are you adding or subtracting? The idea is if these parentheses weren't here, right, that would mean that I'm taking 2 and subtracting 10. But because I have the parentheses there, that indicates I'm taking the 2 times the -10, right? This just means I'm taking 10 minus 2 times whatever that is. And remember that, before you take the 10 and subtract the 2, right, you really want to take the 2 times the 10 first, right? Because you want to do multiplication and division before you do addition and subtraction. Okay, so is everybody okay with that one?
Why is it positive 20 and -20?
Sorry, what was that?
Why is it positive 20 and not -20?
Oh, okay.
Using 2 by a negative.
Yeah, so the reason why, right, because the idea is in this case I'm taking a -2 times a -10, and that will give me a +20. And remember, this, subtraction you can think of as adding a negative, so if you want to think of it this way, right, it helps you, right, so subtracting the -2 times the 10 is the same thing as adding -2 times -10, so that would be 10 plus 20, that would give you 30. So just remember, negative times a negative is a positive. You might think, when I multiply these together, shouldn't that negative sign disappear or something? And then it would look like you're taking 10 times 20. But remember the idea is when you're subtracting, you're really adding negatives. So I'm really multiplying those two together first, getting 20, and then I'm adding. Okay, so is everybody okay with that? Okay, let's do the last example here, and then we'll see how much time we have. Maybe I'll give you guys a little preview of the next section. So the next example says we've got the quotient of -10 and the sum of -6 and -4. Okay, so if you see the word quotient, what does that usually mean? Yeah, it usually means division. So you're dividing two things, but now the question is, well, what do I want on the top, and what do I want on the bottom? Yeah, so I want what on the top? I want a -10 on the top. And be careful when you're doing addition, make sure you get the order right, because like 10 divided by 5 is not the same thing as 5 divided by 10. And so when you're doing division, make sure you're dividing things in the right order. Okay, so I've got that on top. What do I want to put on the bottom? Yeah, so I just want to put a -6 there. Okay. Yeah, so now be careful. It says you're taking the product of -10, and then the bottom is the sum of -6 and -4. So that means I'm adding a -6 and a -4. And I don't really need the plus sign in there, right? I mean, if you're adding a -4, that's the same thing as just subtracting 4. So you're really doing that. So be careful, right? When you look at that, you might be just tempted to say, okay, well, I'm taking -10 divided by -6, and then I'm adding the 4 over here or something. But you're dividing by the sum, not just the -6. So then, again, if you follow the order of operations here, remember there's sort of a set of hidden parentheses here. So again, be careful if you're doing this on your calculator. I guess you don't really need parentheses around the top, because that's already simplified. But just be careful if you're doing that on your calculator, because if you put it into your calculator this way, your calculator is going to think that you're trying to do this. Right, it's just going to take the 10 divided by the -6 and then subtract the 4, because it just follows the order of operations. So if you don't put those parentheses in there on the bottom, it doesn't know that it's supposed to add those together first. So just make sure that if you're going to do it on your calculator, you put those parentheses in there. So let's see. So the bottom will simplify to what? Yeah, that'll be -10. So I'll get -10 divided by -10. And that'll be 1. Okay. So again, just be careful when you're using your calculator. Depending on how you write it or enter it in your calculator, you may be entering something different from what you mean to enter. So if you're gonna, like I said, if you're gonna do this on your calculator, make sure you put the bottom in parentheses, and then that should give you the right answer. If you don't, your calculator will give you, I don't know what this works out to be, but it will be negative. So I guess 2 will go into 5/3 minus 4, right? So minus 5/3 minus 12/3. And 17/3. So if you don't put the parentheses on the bottom, your calculator will give you the wrong answer of -17/3. Okay, so the correct answer is 1, not -17/3. If you try it on your calculator this way, I think you'll see the answer for the decimal. Okay, so again, be careful. Don't always, don't just blindly trust your calculator. I mean, it's just a machine that's programmed to do what it's supposed to do. Okay, so any questions about that? Then? I mean, I think that's basically all there was to that section. See how much time do we have left? A few minutes, I guess. So, one thing I want to talk about here too is there's some problems toward the end. That talk about averaging numbers and things like that, like 115 to 120. Do you guys all know how to compute averages? I mean, maybe that's something you guys are clear on. So let me maybe talk about that. So let's say I ask you to compute the average of the numbers 10, 12, 5, 7, and 8. How would you compute the average of those numbers?
Add all the numbers together and then divide by.
Yeah, divide by the number you have. Right? So add them all together, and then divide by how many you have. You've got 1, 2, 3, 4, 5 numbers, right? And then so just divide by 5. So I don't know what that gives you when you add it all together. Let's see, I guess you'll get 25 plus 17. So let's see, what's 25 plus 17? That'll be 42 or something. So that'd be 42 divided by 5. And you can leave it like that, I guess. But a lot of times you'll want to, get a decimal answer for that. And the idea is the average is sort of the number, the number that's between all the numbers, right? So that kind of gives you an average or an overall idea of what the size of the average thing is in that collection of numbers. So that's all you have to do for those. And then for the last couple problems on page 65, like 121 through 122, they give you some divisibility tests. And this might be something that you might find useful if you have to break things down into primes. I think I might have had a slide here that I hid on my presentation here about factoring numbers and stuff, and so I just wanted to maybe talk about that for a second. You know, the idea is that, and we've kind of talked about this before when we talked about adding and subtracting fractions. You know, the idea is if I give you some number, you know, like 12, 16 or something, you know, the idea is either that number's prime, you can't break it down any further, or you can, you know, break it down into smaller and smaller numbers, right? So the idea in this case is, I guess, that should be divisible by 2. And so, so what is that going to give you? I guess, yeah, it's 6. I guess it should be what, 608. I guess. So it should be 608, and then that number you can maybe break down further into 304, and then you can keep breaking it down like that. But there are other divisibility tests that you can do, and I'm not going to expect you to memorize these or anything, but they're ones that you might find useful. Like 121 is the one I was just talking about. Is if the last number is divisible by 2, then the whole number is, you know, then the whole number is divisible by 2. But there are other more obscure ones that you might not be aware of. And again, you don't have to memorize these or even use these or anything, but they're, you know, they're kind of handy. Like 121 says that if an integer is divisible by 3, if the sum of its digits is divisible by 3. So the idea is, like, you take the number 111, since when you add 1 and 1 and 1 together, you know, 1 plus 1 plus 1 equals 3. So when you add the digits together, if you get 3, that should be divisible by 3. So if I take 111 and divide that by 3, you should get an even number there. I don't know what it is off the top of my head. Let me choose my calculator here. So yeah, so that goes in there 37 times. So that might be one that you don't know. And so like I said, just try those problems. You might find them some of them kind of interesting. And you might wonder, well, you know, who cares about this? I mean, so what if I know all these divisibility tests? And you know, it doesn't really matter, but it might help you factor numbers into primes. And you might wonder, well, who cares about factoring numbers into primes? I mean, well, there are a couple of reasons why you might care about that. I mean, we did that, you know, when we were adding and subtracting fractions. But another reason why you might be, you know, interested in that, like I think I mentioned before, is, you know, all of our privacy is essentially based on the fact that you know, all the data you send across the internet and stuff like that, if it's encrypted, basically all that information is converted into prime numbers. And if somebody wants to, you know, break into your, you know, your bank account or whatever, they basically have to factor a really large prime number. You might think that's not very secure, but you know, it's really hard to factor a number. I mean, if I give you a, you know, a really long number like. And the bank account numbers that they use, I don't know how many digits they have. You know, they've probably got like 100 digits or something, so way more than that, right? Is that number prime or is it composite? Well, that's really hard to tell, right? I mean, it's composite if you can find a number that divides in there, right? Well, I mean, obviously 2 isn't going to go in there. So you can try 2, you know, maybe 3 goes in there. You can try 3, try 4, try 5, try 6, try 7, try 8. And then, you know, I guess you don't really have to try the, you know, 6 because that's composed of 2 times 3. But so you might want to check those out. Again, not anything you have to memorize. So don't worry about memorizing those properties. But you might find those sort of interesting. And then one other thing just to point out here before you guys go is there are some summary exercises on page 66 that sort of combine the stuff on multiplication and addition together. And I'm not going to assign those, but if you're looking for some extra practice to do those, might not be bad things to look at. Okay, so let me just talk about one last thing here then. Maybe I'll let you guys go a little bit early because it's Friday here. But one last thing I wanted to talk about, here's the assignment, by the way, is just to talk a little bit about the next section. So the next section we're going to talk about on Monday, I guess, is a little bit abstract. These problems aren't especially hard, but they're they're going to talk about some of the properties of real numbers. Like one of the properties is the fact that, like as I mentioned before, if you switch the order of addition, it doesn't matter which, what order you add things, and you still get the right answer. You might think, well, who cares? I've known that since I was, like 10 years old or something. Right? You know that if you switch the order of addition, you get the right answer. You might not. Or the same answer. You might not realize that that's an important property, but it's important enough that it actually has a name. That property of being able to switch the order in which you do things is called commutativity. And so the idea then is we'll talk about some properties of real numbers. And again, this might get a little bit abstract, but it's not really hard, and there's not really a lot of computation in this section. They'll give you like maybe an example problem like this and ask you which property is trying to be displayed. And in a way, like I said, these properties are probably ones that you guys sort of already know, even if you didn't know what the name was. And they're not going to be especially important later on. I mean, I guess they might be important from the point of view, if I use the word commutativity, you'll know what I'm talking about. But if you were to go on and study more advanced mathematics, these properties turn out to be extremely important. But for right now, I doubt very much you'd see a lot of questions on the exam from 1-7. We'll talk more about that on Monday. So before I let you guys go, did anybody have any questions about anything else? Okay, so that's it for today then. So we'll do 1-7 on Monday, 1-8 on Tuesday, and then review and probably take the exam either on Thursday or Friday. And again, don't forget to turn in 1-2 before you go. Oh, you can just stick it up here. Oh, I can take it, yeah. I don't know if that video is... Oh, I don't.
Yeah.
Well, here's the video from yesterday, by the way. There's no, I don't know if this computer has audio on it or not. It's interesting that it is on black. Or this isn't from yesterday, I guess because the screen's still on.
Should we take out this whole
Maybe
camera?
it's already been recorded. So anyway, if you want to do these, I'll find there to do
Yeah, I consider it being useful.
Oh,
Is that just the problems we did?
Yeah, it's just the
If there's anything going to add to it,
or I can give it, yeah, Monday.
Yeah, that's right, yeah.
that works. Yeah, thank you.
Yeah, I'm hoping they haven't done that Monday, it's my plan. Not Monday, it should be done by Tuesday.
Oh, I'm sorry.
No, I don't. Are you just gonna hold the edges open and then, or yeah. You might want to put your name in it. Oh. Oh, yeah, that's right, I guess there's crossed. Your name's already crossed out.
Is that just like a new shirt for the band?
No.
No, I can actually, I see that.
Oh, okay, that's okay. Oh, okay, yeah, that's fine.
This is just not your day. Yeah. We should do something fun next week. It seems like you're gonna need it. Well, you work this weekend? Oh, well, that's nice. I have an interview for this one, so.
Oh, where are you interviewing?
Red Rock.
Oh, yeah?
Yeah, I'll be aware. That excites me.
No, I don't. If you just want to put your name on each page and just sort of fold the corners over. So if people say the envelope, you're restaurants.
Yep. We've all had bad mornings.
Some ones from